In this example, we'll find and classify the equilibrium solutions of the autonomous differential equation dy dt equals y times y plus 3 times y minus 2. Recall that equilibrium solutions happen when dy dt is equal to 0. Since this is already factored, we can see here that the equilibrium solutions happen at y equals 0, -3, and 2. To classify them, we will want to know if the derivative is positive or negative around each equilibrium solution. We'll start by looking at when y is bigger than 2. Here we have that dy dt is y times y plus 3 times y minus 2, and when y is bigger than 2, y is positive, y plus 3 is positive, and y minus 2 is positive. So we can conclude that dy dt is positive for y bigger than 2. On the other hand, for y between 0 and 2, the factor y minus 2 will now be negative since y is less than 2. And the factors y and y plus 3 will still be positive, so dy dt is a positive times a negative, which means that it's negative. So we can conclude that for values of y between 0 and 2, dy dt is negative. And when y is between -3 and 0, the factor y is now negative, so dy dt is a negative times another negative, which will be positive. So y will be increasing when it's between -3 and 0. Finally, for values of y less than -3, dy dt will be a negative times a negative, which is negative. So we can conclude that y is decreasing when values of y are less than -3. We can capture all of this information in a phase line. We'll draw it so that our three equilibrium solutions, y equals 2, y equals 0, and y equals -3, are all marked. And for values of y bigger than 2, dy dt is positive, so y is increasing. For values of y between 2 and 0, dy dt is negative, so we'll indicate that y is decreasing with the arrow pointing down. Between 0 and -3, dy dt is positive, so y is increasing up towards 0. And finally, for values of y less than -3, dy dt is negative, so y is decreasing away from -3. And from this phase line, we can see that solutions that are near 0 tend towards 0, so the equilibrium solution y equals 0 is asymptotically stable, while values of y near 2 and -3 tend away from those equilibrium solutions, so y equals -3 and y equals 2 are unstable solutions.